In our first lesson on vulnerabilities, we're going to start with what is a vulnerability. So, you might think many different things, frankly, when you start thinking about what a vulnerability is. For anyone who's been around in the space for a while, you might automatically go to CVEs. And while that is important, and it's definitely something we're going to cover, there's more to vulnerabilities than just that. NIST has a nice definition of it for us. It's very technical. A weakness in computational logic, code, found in software and hardware components that, when exploited, result in a negative impact to confidentiality, integrity, and availability. I like to think of it all like a heist. I love thinking about cybersecurity like a heist, because what we're trying to do is protect something that other people want to get. Now, in a heist, think in a heist movie or real life crime, I don't know. This stuff might actually happen. I just don't hear about it. There's jewels, there's money, there's information that's being stored somewhere, and a group or an individual is trying to get access to it. And if you think about any of the movies that you might watch, I love heist movies, there's so many different pieces that go into it that they have to think about. And there's many different vulnerabilities. There's little things that can be exploited to get in. Now, generally for a heist or bank robbery, you might be thinking about physical vulnerabilities. And that's a layer on the OSI model. We got to think of the full stack of the OSI model. And the physical layer is there. You can cut power, you can cut lines, you can gain physical access, you could get around people. That is very important. And that's something that we have to worry about ourselves when talking about cybersecurity. There are physical controls, and that is something that's really important. Man traps, vaults, proper door locks, gates, fences, lighting, cameras. Those are all parts of physical controls, and there can be vulnerabilities in those as well. Let's move to some more in the computer type things. Cybersecurity vulnerabilities. They, again, are a weakness which can be exploited by a threat actor. And there is a whole course specifically about host and system-based attacks, where you will dive in and learn how to exploit really well vulnerabilities on a machine, usually about the operating system or service running on it. And those are the common places where these technical vulnerabilities come from the operating system itself, or a service that is part of the operating system, or in something that's been installed, a service that's running, that's software installed on that machine. So these can be found either by DevSec engineers, people who are looking at applications, updating them, looking for these vulnerabilities in the products that they're putting out or that they're now working on for their team. Security researchers, got some good friends who go out and do this on the regular for MSSPs or researching firms, trying to find vulnerabilities to better our infrastructure, our ecosystem. Pen testers often find vulnerabilities. The difference between a pen tester and a cybersecurity researcher is a very narrow line. It all depends on what your scope is, what you're doing day to day, but they think a lot the same. Software developers might find their own vulnerabilities. They might find vulnerabilities in other people's code. Again, the lines between these different roles are very thin. Users often find vulnerabilities, and by playing like a user, that's often how researchers or pen testers come across some vulnerabilities. Fortunately, the United States government, in its always putting a lot of money and effort behind things, no matter what, has a national cybersecurity federally funded research and development center that worries about CVEs, that tracks the CVE program. CVEs being common vulnerabilities and exposures. And there's a CVE website that is managed by MITRE Corporation. They maintain the system and a lot of the logistics behind it. And it's funded through the National Cybersecurity Division of U.S. Department of Homeland Security since 1999. Or at least it's been around since 1999. Homeland Security, not so much. We've got NIST, who maintains the National Vulnerability Database. It's very similar, very related, and we will take a look at both the CVE page and the National Vulnerability Database. Now, CVEs have identifiers. They could also call it a CVE name, number, IDs, or just CVEs. CVE blank. A few that we're going to look at: CVE 2021-44228, log4j. If you're seeing this and this is a fresh course, you might not want to hear that term, log4j, right now. CVE 2014-0160, which was the Heartbleed vulnerability. We'll dive into that one. And then CVE 2017-0143, or MS-17010. Also known as Eternal Blue, part of the WannaCry ransomware, and NotPetya, and a few others. These are vulnerabilities that had high impact or were critical vulnerabilities, and we'll dive into what all that means with some examples in just a second. The things that we kind of need to understand and get comfortable looking at are the vulnerability details pages. So there's going to be a description. It'll go into severity, and we'll talk about severity while we're looking at the page. And there's a nice tool that we can look at to kind of weigh the severity ourselves, the criticality, depending on our situation and how a vulnerability actually goes from the impetus to being exploited or used. Some weakness enumeration and references, what white papers, what exploits, what proof of concepts have been collected as part of the database. Again, weakness enumeration, what do they produce, or what has been collected, so that these vulnerabilities can be found more easily by vulnerability scanners or other research firms. And then known affected software configurations. That's also quite important. Those are things that as a pen tester you might want to become familiar with. Some of the obvious ones come out at you, and we'll talk about those when we get there. But others, if someone is implementing these software configurations, they need to be aware that the vulnerabilities exist in them prior to implementation. And we'll get to it later, but accepting certain levels of vulnerability, certain levels of risk, this is kind of up to the organization, but they need to be aware what is out there. So we're going to swap on over to the CVE page. This is CVE 2021-44228, log4j. And let's take a look at what we've got. We have the CVE ID, and there's a link to the National Vulnerability Database. They are interconnected, and we will look at both. Then we've got a description. And so this one, it says that Apache Log4j 2.0 beta 9 through 2.12.1 JNDI features used in configuration, log messages, and parameters do not protect against attacker-controlled LDAP and other JNDI-related endpoints. Now, this might not make any sense to you right now, and that's fine. In the next lesson, we're going to go into the details of what all this means and what it means for an attack. But you can see here that there's a description of what's going on. There's some technical jargon. And if you aren't a programmer, if you haven't worked with Java, if you aren't familiar with LDAP, then this might not make a lot of sense to you, and we will get to that in a little bit, I promise. But the important thing here is seeing that there is an explanation of what's going on, and we can read that and use that later as you become more familiar with all of these things, because that's kind of what's required in cybersecurity. Become more aware of the different technologies, the different languages, the different software being used, and how we can either utilize it for pen tests or help organizations become more secure by pointing out the vulnerabilities and being able to explain this and why this is a problem. That's going to go into our report. We need to understand what this means. If we exploit it and we can't explain why it matters, then there's no value in our report, right? So that's important to understand. I'll give you the full screen so you can see better. It goes into some more detail, some more versioning. That's fine. There's references, and these can include proof of concepts, articles, white papers, and these actually feature different versions of software here, which is kind of useful. You can see who the assigning CNA is, and that's the CVE Numbering Authority, the CNA. This one, it's Apache Software Foundation. Apache owns and produces Java and Log4j, so it kind of makes sense. See the date created, came out at the end of November 2021, and the date reflected when it was allocated or reserved, not necessarily when it was discovered. So that's important to know. All right, that is the CVE page. Sometimes there's some more information, but this one usually just launches you to the NIST National Vulnerability Database. Now we see the same information, CVE 2021-44228, with details and another description. These are very, very similar. Pretty much the exact same language. Now here, there is analysis description, which in this situation is the exact same description. That's fine. If it gets updated, then this information might change, and that's perfectly fine. That's good. You want the most up-to-date information in the database, correct? So here we have a gauge of severity, and there's an older version and a newer version. Tend to just look at the 3.x, but there is debate on which one is more useful, and we'll dig into criticality in just a second. I'll come back up to it. There's the references to advisories, solutions, and tools, and in here there's websites talking about how to utilize it. We should have some tools and proof of concepts in here. And then we get into the weakness enumeration. So they're created by these sources. So either Apache themselves or NIST alongside Apache came up with CWE IDs, and we could dive into those and what they mean. But basically, the weakness enumeration then is part of identifying how this could be solved in the future and avoided. But your known affected software configurations are critically important. The CPE is hugely important, and if you're at all curious what a CPE is, NIST has this understanding vulnerability details pages, and description is description. It goes into explanation of that. Explains severity, references are what they are. But your known affected software configurations, this common platform enumeration specification, is very, very, very important. This is how vulnerability scanners are then going to take this signature, if you will, to find the vulnerability throughout an ecosystem, throughout a network. And you dive in and read the heck out of this. It's worthwhile to get an understanding of it, and if you are searching for a specific vulnerability, to become familiar with the CPEs. but there are a lot of configurations. Java is used in a lot of places, and over 84% of Java applications utilize the log4j library. So there it is. All the places it is used. Which I'm going to use that to bring us back to this base score for criticality. And you can see if I hover over the critical right there, it highlights. We can click on it, and it brings up the scoring calculator. Now, there's some base score metrics, and that 10.0 was a very big part of it. And a lot's based on how the attack vector gets in. It comes through the network. You have to be on the network. Some of it you need physical access. You just need local access. You can be on an adjacent network. That will change your base scores. The complexity, it's not a very complex attack. If you're exploiting the vulnerability, doesn't require any privileges. User interaction is low. You don't need someone else to click on anything. The scope in this situation has changed, and you can get into the details of what all that means if you really want to. And then there's the impact. And again, impact is going to be the part that really is going to matter to our customers. They want to know, and that's the customers or our pen tests or our security analysis, if you will. Whoever it is that we're turning over the results to, and whoever is going to take this and run with it, they need to know what the potential impact is. And so that's why these are worth looking at. Confidentiality, integrity, and availability are very high for this, because if exploited, they can run whatever code they want, and you could change data, you could deny data, you could steal data, and that's all three. That's all three sides of the triad. Now, if we dig in a little more, this temporal score, you could see there are functional exploits that exist because it's been exploited. The remediation level has an official fix. Java has put out a fix, and a lot of organizations are implementing those changes. A lot of software vendors in this situation had to update. Once they updated their Java, then they had to update their application, and then organizations needed to then patch that software once the patch was available. And there is confirmed report confidence. So that's high. And then if we look at exploitability metrics, this is where we can see an impact on the score in a high way. Already, by changing that temporal, it dropped down to a 9.3. That still matters. That still matters a lot. But if you only need access to the network, you could be actually in the network. The complexity is still low. If you find a place to do your JNDI injection, then the rest kind of falls for there. It's not very complicated. Don't need privileges usually. User interaction is none. You don't need anyone to click on any links and emails. In this situation, it shows you what unchanged versus changed means. We went with unchanged, and then high impacts. And here, requirements is useful. And again, these ones are going to be high. We can see how the modifiers change the overall score. Now, in the end, doesn't matter that much. It's still a 9.1. So the severity, it's very severe. Then it becomes, okay, what's the impact? If they have something that's publicly facing that anyone can attack, and it takes down the whole server, then that's not good. Especially if they don't need to be authenticated and there's no way of protecting it. Now, during your pen test, you will find how critical it actually is. If it's exploitable, you can say how you exploited it and how easy it was to do, and give recommendations for remediation. What could they put in place to avoid that and stop it? If it's as easy as patch the software, that's one thing, but what if they can't patch the software? What if it's a application that requires that older version of Java, that requires that older version of Log4j for some reason? The software vendor that created the software that's being used by the company, maybe they've gone out of business. Maybe they can't patch. These are all things that need to be taken into account when you're making recommendations from your pen test, from your reports. Now, those are our vulnerability details pages, both from CVE page and the National Vulnerability Database. And you might be wondering about zero-day attacks. These vulnerabilities that we were looking at have all been submitted to the CVE numbering authority, and they have determined that it's worth actually posting somewhere to the CVE database. Now, there's going to be exploits out there for vulnerabilities that haven't been found. That we call a zero-day exploit, meaning no one else knows about it, or no one else has exploited it, or no one else has at least reported it to the CVE organization. Many pen testers like to find 0 days. It bolsters you as a pen tester in a lot of the community for finding something by going through the fuzzing steps, by doing the research, by identifying something that the developers didn't find that no one else found. And there's a lot of prestige among some pen testers for finding and utilizing 0 days. And that's neat. Software is going to be vulnerable, and if you can find one, utilize it, help the ecosystem, help the industry by identifying these things, putting them in your reports, and sharing them with a numbering authority, that's going to help everyone. And that's all good things. Now, not all vulnerabilities are computer code. Talked about this when talking about heists and physical security. You've also got layer 8, the people. Often social engineering and utilizing interpersonal skills are going to be just as helpful for a hacker or pen tester in order to get access to information or the network as a whole. That can include using known social engineering techniques for passwords, or taking advantage of maybe some of your physical operational technology controls, such as card readers or access badges. If you can make up an access badge that looks like it's good, and you know that the guards don't check that well, and there's nothing stopping someone from tailgating perhaps through a gate, if there is a gate, then that's an easy way for an adversary or a pen tester pretending to be an adversary to get in and get physical access. If you get physical access to a network, then it changes the game. There's a lot of things that you can do internally that will give you more access than if you were trying to attack externally, maybe through like a web server or externally facing services. Again, scope, impact, and usefulness will all come down to business needs. Smaller businesses might look at things differently. Giant corporations might look at things differently. Hospitals or banks or specific organizations with specific needs and compliance and regulations are all going to have different requirements. The management of all this goes alongside business risk management into overall risk management. Some risk management has to do with mergers, acquisitions, hiring, firing, a lot of different parts of the business that aren't at all technology, IT, or cyber. Including cyber in there will help the organization as a whole, and you need to understand your recommendations go into that overall risk management concept. Even if it's a small organization, they don't have a foundation or a framework for risk management, they're going to be doing it at some level. They're going to be sitting down and deciding where are we going to spend our money and how are we going to use it. And if it's not formalized, it's still happening. And your recommendations for cybersecurity are going to get included in that, and they might get prioritized lower than what you think they should as a cybersecurity practitioner. So this is a course about pen testing. So you might be wondering, when are we going to get to that? And risk management includes vulnerability management, which is what we're covering here, and vulnerability assessment. In order to manage your vulnerabilities, you need to know what they are. With that, there's vulnerability scanning and pen testing for gap analysis, because often there might be a level that you might know what software you have, you might know that it's vulnerable, and you might assess the risk that it is behind the network boundary, internal only, and the impact of it is low enough that it's not worth spending the time or the money to update it. And that's up to the organization to decide. You can make your recommendations. I bet I know what recommendations you would make, because I would make the same. Let's mitigate as much as possible. But as a pen tester, as running vulnerability assessments, doing that gap analysis, it's all going to be part of this chain. So how do we find these vulnerabilities? We've done footprinting and scanning in this pathway. We've done some service enumeration in this pathway. That's all going to be part of it. Asset identification and research. Okay, hey, there's this service running. It's this version on this operating system. We need to go and see, what does that mean? And we'll get into that in the lab. But there's places like ExploitDB and the on-hardware version SearchSploit, maintained by Offensive Security, and it's a great asset for the community. Or there's fuzz testing. You might get access to something and not be able to find any vulnerabilities that are out there in the wild, that are known. So perhaps you need to try some things and see if there's a vulnerability there. Input and handling validation is important, and that's, again, how pen testers find a lot of things. You try putting in passwords that don't look like normal passwords. You try usernames that don't look like usernames, because maybe there's a chance for SQL injection. Those are things that we'll get into in other parts of this pathway and other courses, but that's generally how we find vulnerabilities. In the next video, we're going to take a look at some well-known CVEs. We'll look at why they mattered and what we can take from them now today. Even though a couple of them are a bit older, one's fairly new and relevant, and I think we'll learn a lot.